The title of my talk today is Sensor, Data and Prediction, the Holy Trinity of the Internet of Things. So I come from the company Hitachi, and Hitachi has 100 years of experience in operational technology. So it's manufacturing, it's trains, it's all this logistics, it's all this machinery, and the experience of Hitachi is very long. But now it comes to the next stage, because all these devices, they're equipped with sensors that collect an enormous amount of data. So it's a time series data generated by these devices, and these devices are connected to the computer network, and that's what we call the Internet of Things. The Internet of Things market was estimated to reach 267 billion by 2020, and the analysis, capturing of this data and integration of this data is the core of improvement of the operational technology. That's why the vision of Hitachi needs to be changed to use this data for analysis and prediction. So why is it important? If you're a manufacturer and you produce goods and you do logistics and selling them, you go through the complicated logistical process involving lots of heavy machinery equipment, fleet, like, I don't know, distribution of cars and supply chains. And if you have breakage or stoppage in anywhere on this sort of journey, you have a significant loss in profit. So the ability to use the data generated at every stage of this process gives you an opportunity to predict potential failures, to reduce the downtime, and to improve your business operations. And but it's not that easy, because first of all, it's amount of the data that's generated by these devices. And another thing is complexity of this data. So it includes unstructured, semi-structured, and the traditional data sources as well. So it starts from unstructured data, such as sensor data. It can be video data. It could be audio data as well. It could be machinery logs, workloads, and geolocation data, and also traditional data sources. So our vision is that having a consistent end-to-end IoT platform can simplify usage of the IoT data for improving business operations. So to implement it, you need to start with ingestion, processing, blending, preparation of the data, application of the advanced analytic techniques, and the interface for action and decision making. And to do that, you need to rely on 3 core components, such as sensor and capturing, integration and blending, infer and act. Sensor and capture, it's, first of all, if you go to the factory, you see machinery, right? It's not very straightforward to know how you can actually capture the data and how would you use this data to apply advanced analytics. Sometimes it's just a machinery, so you need to register the sensor data coming from it. You need to create a digital twin and avatar of this device, and you need to build the architecture for capturing this data and building the data lake for storage and further processing and analysis. The next thing is you need to do the data refinery. So you need to build the whole pipeline, and data coming from one machine alone is not sufficient to build predictive solutions. You need to blend it with contextual data. So, for instance, if you're a fleet manager, the breakage of your vehicle can depend on factors such as weather, the road, and other external components. And so the ability to refine this data, to blend it with additional data sources, and to shape it in a form that is sufficiently good for mathematical models to work with is a crucial step. And that's what comes the analytics, machine learning, reporting, and alerting capabilities. So this is analytics is one piece, but another one is to be able to act on that. So your data pipeline needs to be consistent. If you are a fleet manager, you need to have a solution that has all these components in a streamed way, so you predict your breakage of the vehicle 1 month in advance, so you can act in a timely manner. If you build a solution that predicts that the car is going to break in 2 minutes, it's not sufficient. And or if you, I don't know, if your solution is not relevant to the machinery at all, that's another problem. So I'll give you an example. So once I was on a steel factory, and we were trying to build the use cases around improving pickling line over there. So they wanted to reduce the downtime of the pickling line. And first of all, as a data scientist, I had no clue how the steel factory works. So I was just walking around the machines, and I had no clue how they operate. At the same time, when we spoke with the factory workers, and we asked them, so how do you know of the potential breakage? They said, well, the control room is shaking. That says how we know that the trouble is coming. So it's building these IoT solutions is, first of all, it's a multi-stage process, and second of all, it's a combination of multiple experience in operations and advanced analytics and knowledge and tooling. That's why we think that this is 3 stages are the 3 components of the IoT platform. Now I want to walk through the hypothetical example to put all these things into one consistent perspective. And after that, I'm going to give a couple of examples of our existing use cases and how usage of IoT data plus advanced analytics and data science resulted in a real savings. So let's start with a hypothetical fleet company that we'll call Big Fleet. We have 222 vehicles, and we have different types of vehicles. So first of all, what we do, we create an asset avatar. So it could be a heavy vehicle, light vehicle, and utility vehicle. We identify the ID of each vehicle, and we register all the sensors associated with it. So we see, for instance, if it's a car, we have an air pressure, vibration, movement, temperature, and other characteristics. And I want to predict when the air pressure in the wheel of the vehicle is going to go down, so it breaks in the middle of the road and my goods are not supplied in the right direction. I use sensor data, plus I use the contextual data that I blend to build a reliable and comprehensive model. So I can do things such as monitor fleet status and health. I can do recommendations for the repair of the vehicles, and I can also predict the breakage of the vehicle. And then I can act on that. So in this particular example, we quickly walk through the several components of the IoT platform. So it starts with the fog layer and core that is related to the asset management component. The fog layer refers to sensors, things, and people. So it's basically devices and people that generate data. And core is the registration, this Internet of Things as an asset avatar. And the next step is the data refinery. When we onboard this data into the data lake, we build the data cleansing pipeline, we blend it with the other data sources, and then we move to the next stage when we do machine learning, visualization, and act accordingly to improve all the operations. And as a part of the IoT strategy, Hitachi acquired the company called Pentaho, that is a platform for data integration and business analytics. And this is the architecture that is implemented in the IoT projects. So Pentaho data integration tools come in multiple stages of the data pipeline, starting from the connectors to the Internet of Things, go into the data refinery and also model application and storing the data in the relational database, as well as building dashboards for decision making and support. Now let's go through some of our use cases. And the first one is Hitachi Rail Europe. So this is a Hitachi train, and this is a high-speed, very new technological train. But the thing is, what you don't want to do is to have this train breaking in the middle of the rail network, because it would result in the enormous losses and enormous payments in the compensations. So to solve that, we need to build an IoT-based solution. For this particular use case, the challenge was, first of all, it's too many data points. It's petabytes of data. It's difficult to analyze. It's difficult to visualize. And the solution is to build the end-to-end platform, is to build the data lake, is to build the sensor processing pipelines. And as a result, there was $1 million of savings in the maintenance. The maintenance was based on actually the doors of the train. So first of all, you would think that the breakage of the train occurs due to rail itself, but actually the doors of the train is also a very important factor. The train cannot move if the door cannot close. So in that particular application, the sensors from the doors of the train were used as an IoT asset. So the sensor just gives you the number, the door is closed, the door is open, but by tracking the changes in this pattern, you can predict that the door is going not into ideal operation and fix it before train stops in the middle of the rail network. The second example that I want to give is Veikkaus, that is Finnish National Lottery. And the challenge that they had is they wanted to capture customer behavior in order to do targeted marketing and predict the gambling addiction. I don't know how one links to another, but they wanted to serve both. And they had 200,000 terminals, and they were struggling to do reporting and blending of one data of the terminal data with other contextual data. So by building the IoT architecture and the implementation of advanced analytics, eventually they were able to reach their goals for targeted marketing or tracking patterns that would identify gambling addiction. And the last use case I want to talk about is Caterpillar Marine Intelligence. And the Caterpillar Marine Intelligence is the company that tracks ships' operations. One of the, first of all, one thing you want to avoid is the big container ship stopping in the middle of the ocean. That would be a disaster. The second one, the ship is using fuel to move, and it's expensive. And another thing that the usage of the fuel of the ship depends how clean the hull of the ship. And to do the cleaning of the hull is very expensive itself. So they wanted to optimize when it's relevant enough to do the hull cleaning, but when the hull is not dirty enough to just waste fuel all the time. And first of all, the way they achieved it, they were able to onboard all the data, all the sensor data generated by the vehicles, the ships, and they were able to blend it and analyze it. And in this particular case, the data integration was a big enabler because, first of all, they took the low-hanging fruits. So by just being able to visualize the data and see basic relationship, they reached a significant savings. So for instance, they adjusted the power to operate generators, and it results in 650,000 of savings. But their optimization of hull cleaning resulted in 800,000 dollars savings per year per ship. And this is just the two main savings. They also optimize the usage of their air conditioning and their idle time in many, many use cases that resulted in significant savings eventually. So for them, the sensor data collected by ships was resulted in a clear and significant profit. Just to sum up, that the IoT is new, is exciting, and the opportunities are endless. And the vision of Hitachi in this case is to combine the years of operational technology experience with IT experience that is around 55 years to build the reliable and profitable solutions. Thank you.